Very excited to be here. So we're going to start with talking about connecting, sharing, and collaborating. The story starts, again, 300,000 years ago around a fire. We all heard about the technology of the fire. But I'm going to talk about another part of this story of the fire. It's the sharing of information. We had time to sit down and communicate. It's the personal connection that makes a difference. We had the ability to plan for the next day, for how we were going to live our lives. And that really hasn't changed. Technology, another amazing technology came around thousands and thousands of years later that we were able to actually capture our decisions and share them with the next generation so it wasn't lost only in conversation. This was a tectonic shift in civilization, as we all know, amazing technologies. Fast forward to today. Cities are incredibly complex. There's a lot of moving pieces. There's a lot of challenges. How do we capture these decisions that we make? How do we know how much energy is being used in a city? How do we even make decisions? Because there's so many different pieces that are piling on top of each other. It's a daunting task, and that's what we're here today to talk about. I'm an architect, and the thing that has drawn me to architecture is the ability to connect the science and the art and everything else that goes on about connecting with people, connecting with cities, connecting with buildings. We imagine places. We think about impacts on the environment. We think about creating beautiful places with using poetry with light and gravity to create places like this. We capture our decisions with tools, amazing tools, that started with paper. Obviously, this hasn't changed very much from where we were back there in the Egyptian age I showed earlier. And one thing that drew me to this story that I'm about to tell you is in 1988, I was looking at a document like this, and sitting across the table from a large government organization, I'm not going to name the organization, and I was negotiating a contract. And the discussion went like this. I see on your proposal that you're proposing 85 sheets of documents for this project. Can you reduce the scale of half of them so we can reduce your fee, which is basically pounds per paper? And I kind of looked at them and I said, okay, well, we were using CAD at the time too. And I said, well, I could put it on a postage stamp for you if you'd like and really save you a lot of money. So I started thinking about this and thinking about the decisions that we make as architects and designers. We're putting it on paper, and there's a lot of effort that goes into capturing these decisions on paper. Very valuable decisions that have a huge impact on the life cycle of a building in a city. How else can we look at information about this in a different way? So let's talk about a few problems we have in architecture. If you go back in history, there's the problem of gravity, and we call these issues that happen in design. So gravity caused this, and there's obviously some foundational problems going on here. And we think, okay, this was in the past. But amazingly, if you look today on the internet and you search architectural disasters, there's actually quite a few. Here's one of them, a very interesting one. This is in Las Vegas. It's a new hotel, nice curved front. What happens here is that the sun circulates around and it hits this part of the hotel and then reflects down here to the pool area and singes people that are sitting here by the pool. And it moves around the pool. Well, obviously, this could have been avoided if you simulate the potential problem. And here comes the next part of the story. I love train wrecks, and I love this picture of a train wreck because it's mass transit and architecture kind of coming together. Amazing picture. I love train wrecks, but I love train wrecks to see the train wrecks before they happen, to predict the future. The way that you predict the future is to be able to collaborate and communicate with people and say, what is the potential impact of creating a curve facing south in Las Vegas with a pool over here? Well, there's obviously a discussion that should happen there. And unfortunately, from what I saw, there's a pattern that happens in design and architecture and planning cities and planning buildings that we make the same mistakes over and over again because we're not communicating to the next generation, don't forget about this impact. And we see that happening again, right? So the challenge really is, how do we communicate and break away from our what we call information silos? Information silos are different pieces of information. I have information about energy, I have information about structure, I have information about architecture, I have information about how people live in cities. And those tools and those processes are not talking to each other. Therefore, you miss opportunities of saying, if you do this, there's going to be an impact of a train wreck that happens here. And it also carries into our tools. If you think before the internet came around, we had a lot, and it still happens today, there are a lot of different tools out there that don't talk to each other. You have to export from one tool, import it into the other tool, and you lose information along the way. We're architects and also a software developer, so I can see this, that in the past, the strategy for software development teams was, how can we sell you something that you're going to use as a piece of software that you can put all of your great knowledge and information into, and then how can we make it so difficult for you to take your knowledge out of our tool and put it into our competitor's tool, and on and on. So it creates this kind of compartmentalization of information that is really not supportive of being able to make informed decisions. I'm not suggesting that technology one replaces the other. So when we came to this point, we still had this kind of conversation going. When we came to paper, we were still going back and having conversations. And even today with this, we're still having conversations like this. And with tablets and smartphones, we still are doing this. One does not replace the other. But if we don't move forward, we're still using this to design our buildings today. We're not capturing knowledge in a way that is already possible. The younger generation already knows it. This has completely changed everything in the last few years. The ability to walk around with a smartphone that tells you what's going on around you, to have a heads-up display. As you're driving around, for example, you can find the cheapest gas on your smartphone, for example, right? That would not have been possible years ago. I was driving around with this and I looked at this price a few days ago. Wow, it's over $5, and snapped it on my smartphone and sent it to somebody on the other side of the world and said, here's what's going on over here. So the sharing of information is natural to today's civilization. Facebook, when it first came out, everybody said, oh, what a cute little tool. We can communicate with our friends. Wow, well, this is really great. Well, look what happened with the revolutions that have been happening. Facebook has supported revolutions around the world because people can connect with others in the city or around the world in ways that were not imaginable just a few years ago. So this has changed our definition of what a city is. A city is a global city now. It's a global city because we can connect and make decisions and have discussions about what's going on around us and move on. Okay, the next part of the story is, as an architect, I thought in my work, I travel around a lot, I need to be able to connect with my teams, with my consultants, with my people in my office, with my clients through the internet. And I was doing that since the early 90s, and I said, what if we open this up and make it open to anybody? We do something called BIM Storms. BIM Storms are like a brainstorm. BIM is a tool that's used in the architectural industry called Building Information Modeling. It's about information modeling about buildings. We took that and we web-enabled it and connected a lot of different tools to it, and we opened it up to the industry, to anybody that wants to jump in. We've had over 30 BIM Storms in the last 4 years. Here's one of them, one of the early ones. This is Penn State. Penn State was working on a Los Angeles BIM Storm, which resulted in 420 buildings, 24 hours, 420 buildings, 130 teams from around the world with several hundred people participating in real time and having a discussion about how a city should be designed. You notice these students have different things they're doing. One of them is looking at the plan of the city, another one's looking at a building over here, they're probably looking at cost estimating over here, this guy's updating his Facebook page. Very important things happening here, but this is the generation that expects nothing less than this level of connectivity in the building industry, in planning our cities. And they go into offices. As an architect, I've seen this. You're shocked when you walk into a modern office because it's still being done pretty much the way it was in the 18th century. We're using some modern tools, but it's still about replicating that process that was done several hundred years ago. So that's really, really bad, but it's really, really good because it's a huge opportunity for us to help change that, to jump into that. The other thing that I've noticed is this economy the last few years that's been really bad. It's just horrible what's happened to the building industry, but it's one of the best things that's happened. It's created new opportunities because if you have constraints, you come up with creative ways of solving those. If gas was 10 cents a dollar right now, we would not have the type of cars and solutions that we're seeing in the earlier presentations. So constraints create opportunities. BIM Storms have been theoretical 24-hour events. We've had over 30 of them, but they've also been applied to real-world projects. This is with the National Capital Planning Commission in Washington, D.C., where many teams and government agencies collaborated online with many different tools to capture things like what's the existing energy use of the buildings and how do we reduce them for an eco-district? What are the opportunities? It's impossible, if you imagine the amount of paper that would take to document all the potential decisions that can be made, If you look at the internet and you look at your smartphone and you can search any flight that you want to get on from here to New York, imagine if you had to print out every schedule and put it in a binder and put that binder on a wall and go look for it 2 weeks later to find that ticket. That's how it's being done in the building industry still. So we said if you web enable it and it's real-time data and it's streaming to you and the graphics are changing and you have that heads-up kind of display, then you can have a conversation. And the most important thing is this is not about the technology. It's the ability to communicate and say, I'm thinking of reducing the energy use in this is a HUD building actually, in Southwest Eco District in Washington, D.C. What are the opportunities? What can I do to make that energy reduction? I can change the roof, I can change the mechanical systems, et cetera, et cetera. One of the BIM storms, actually, we had one in San Diego, and this is a representation of all the square footage of San Diego downtown in an inverted pyramid, color-coded by slices by use, and the size of the box as it goes up. So you're taking information. In the information age, this is the currency. The currency is information and the ability to communicate, and communicate it in a succinct way. This is a BIM storm that's actually happening right now. In fact, this weekend, there's a lot of activity on this. This is Oklahoma City. Another train wreck, actually, I think this was. They had a freeway that's going through. We had a lot of freeway stories recently with urban development, right? Old freeway from the 60s going through downtown. It sliced the city apart, and they're moving it to another part, and they're redeveloping this area. They've actually created a new riverfront, and this is a whole redevelopment area right here. It's called BIM Storm Oklahoma City. The City Planning Department of Oklahoma City is working on this. Oklahoma University, and this is a kind of a snapshot live view of geographic data. We're used to seeing geographic data on our smartphones. Where's the nearest Starbucks? Well, why can't we do that with our buildings? Where's the nearest utility line? Where's the nearest building? Where's the nearest parcel? How much energy is this parcel using? Will a new building fit here? What is the impact of traffic as we put more population down there? How does the streetscape look? Can we communicate with other experts as I'm putting this building there? So this kind of real-time interaction allows the decisions to move forward, because in the past, a lot of these architectural decisions and planning decisions were captured, and still are, in static documents, mailed to somebody, 2 weeks later make a decision. Meanwhile, the train keeps on moving, and the decision is stale by then. So it's not only about speed, but it's about the ability to capture those decisions and to capture knowledge and to be able to keep moving forward. Next story. California Community Colleges has 2.4 million students statewide. It's the largest secondary education system in the world. It's the population of Chicago, so it's a city. There's 2.4 million students, and there's more that want to get in. This is a project that's been going on with them to capture their data that's in tabular format in a database and put a dot on a map, just like Starbucks. Well, here are the community colleges. Each dot is a campus. You click on a dot, and there's buildings. There's 5,200 buildings in the community college system in California. 5,200 buildings. If you took each room out of each building and put it side by side, it would stretch 680 miles. We actually did this. We calculated because we have that data. So now we could say, and it tips California on that side because it's so big it can't fit on this widescreen thing right here. So it can fit, all the campus buildings fit on 24,000 acres. It's larger than the city of New York. So the point here is this massive amount of data and buildings. 72 million square feet, 32 Empire State Buildings. They run billions of dollars, $6 billion a year to run energy, water, all that stuff. And as you can imagine, it's been not really always very efficiently used because there's not good information about how to use it. Again, goes back to if we have good information about our cities and our buildings, and not only new buildings. New buildings are great. As an architect, I love to design a new building and talk about energy efficiency of that new building. But a majority of our energy is being used by the existing infrastructure, and we need to figure out how to do both. We can't wait for all the buildings to be new to reduce energy use. So the California Community Colleges has a tabular, they've had for about 10 years, this list that says, well, here are all of our facilities, 5,200 buildings, here's how much money we're spending, here are static floor plans just on paper and PDF files, and here's geographic location of that, of each campus, and here's data about demographics and use in the buildings. And we did is we connected this with what I mentioned earlier with BIM, with Building Information Modeling, in a web browser, and connected many different tools, the geography tools with the information about buildings, with the information about the space, with the information of color code the spaces with which room has a light on, for example. These buildings are getting smarter now. The technology is at a point now where buildings are starting to talk and say, my lights are on, my lights are off, here's my temperature. Just like our smartphones, we're broadcasting information about ourselves. Why can't buildings do the same thing and talk to systems so that whoever's making decisions about how to reduce energy in a building, for example, can see those decisions? Here's Miracosta, actually, near here in Oceanside, with utility information. And you drill down into the building, you can see the floor plan of a building. The floor plan is not static, just like that plan of when you reserve a seat on a plane that's constantly changing. The data that changes the buildings. Buildings are not static. They're constantly moving. They're constantly renovating. They're constantly changing schedule. They're constantly changing how the energy is being used, changing systems. In order to manage that complexity, we need to have this live data coming to us. As an architect and as planners, we need to figure out how we can get that information and knowledge out of that 18th century mode into the 21st century. Pretty exciting stuff. There's a lot of opportunities to jump into something like this and collaborate on projects statewide like this. And the same thing's happening in different parts of the country with different owners. You can take these buildings and start doing simulations of how the wind is going to go around and how energy is being used. A lot of really amazing tools that are starting to connect. These tools on the internet, like I mentioned earlier about the maps, they're called mashups, where you can layer different tools together in very simple format. It used to be very difficult and very expensive even just 5 years ago to do this, but now you can actually, simple apps, you open an app and you have a map and you can start doing things with that. Same thing's happening today. This is a detailed building information model of a mechanical system from a company called Balfour Beatty, and the completed construction. So these models are starting to get very, very detailed and have very detailed information about how much energy is that piece of equipment drawing, for example. And as the buildings start talking, there are live charts that say, here's a daily energy use of that building coming from a single building, or here's a roll-up chart so you can see how your whole campus is doing. And show me trends that are happening and issues that are coming in and requests that are coming in about something that's too hot or too cold from people that are in the buildings. So these are all conversations that start happening, and having those accessible in a smartphone, in a tablet, that's completely changing the way the industry is working. A lot of people think of smartphones and tablets as tools that you just consume information, but there's people that are interacting with this data. When you see that, you can start creating action with it instead of having to go back to your desktop, for example. So pretty exciting stuff. So like I mentioned earlier, none of this negates the need to be able to communicate. It just makes it easier to communicate when you have this heads-up display. We can have a conversation, and more importantly, we can capture all the great knowledge and information that we have at events like this at TED. It's great to have that, but how do we capture that and say, here are great ideas. If we put these two great ideas together, there's going to be something bigger that can happen with that. So it's all about knowledge sustainability. We think of sustainability about energy, but I look at it like if we can't capture our knowledge and decisions, it's really an unsustainable way of making decisions about planning and designing a city. We're literally doing things over and over again and making the same mistakes. And by doing that, we're actually wasting energy, collecting and recollecting and throwing things away and trying things out and having the train wrecks. If we can